Try to have some breaks so that you can intermingle and talk more. I guess the whole process behind this, why I'm having this day today, or why we're coming together, is I think all of us know that there's profitability issues on the farm right now. That just doing the same way we always did it definitely isn't working as far as economic wise. So we're not necessarily going to talk about individual products. I've used some products on my farm, and there's a lot of people in here that'll talk to you about some products. But what the whole thing is just stretching your fertilizer dollar, making fertilizer go further. So we are going to talk about some things that might be a little bit higher level concepts. So don't be afraid to just ask questions. There's a lot of times where I feel like I'm drinking out of a fire hose, that we're just learning stuff every day. So it's okay to ask questions. There's no dumb questions out here today, and that's how we learn, is to ask questions. So if anything is, we're going to give everybody a question and answer time afterwards. And I'm going to start off today with Sarah Montgomery. Her and her husband Tyler farm in the area, and also have a little group, SPPA. So if you're ever back in Almena in April time, you can come see some tractors and classic farm equipment. And we'd love to have you back. But in the meantime, Sarah, she does ingrained, and she has her own mineral company, I guess you say. And through SPPA, I've learned that she actually knows quite a bit about nutrition. So she's going to share a little bit about amino acid nutrition and getting nutrition into a plant. So she's going to have a little presentation. I think we're going to have time for question and answers afterwards. So we'll start off and let her go.
Well, we'll make this work. Well, thank you for that introduction, Michael. It's been great getting to know you guys as I've been in Almena more and more. Like you said, my name is Sarah Montgomery. I farm with my husband Tyler in this area. We also own territorial trading, so some people know us from that aspect. And I am also the Vice President of Research and Development for a company called Tracer Minerals. We started in the animal sector, have moved into the plant sector in the last 5 or so years. But I specialize in amino acid chelated minerals in plant, animal, and human nutrition. So I was asked today to talk a little bit about amino acids and how can they work in your program. So I figured before we jump into the why, we probably need to talk about what an amino acid is, just to give everybody that base knowledge. So the best way to think of an amino acid is to think of it like a Lego. An amino acid is the base unit, and that's just a diagram, is the base unit for your proteins. Every living thing that we work with, every living thing there is, has to use proteins in order to perform cell functions. So amino acids are your individual building blocks of Legos. They come in different colors, different sizes, different configurations of dots on the top, and those all go together in a certain sequencing and make your proteins. The other thing to note with amino acids that make it a unique essential nutrient is this nitrogen right here. And this kind of starts to look familiar, doesn't it? So let's dive in a little bit more. So here is that same amino acid up in the top right-hand corner, except I've added another hydrogen onto it. So when you do that, that looks familiar because that is actually anhydrous. We use this all the time. This is why we supply nitrogen to plants, predominantly to make amino acids, and also to there's some chlorophyll, some genetic material manufacturing that happens in that too. But really, we feed nitrogen to plants. That plant takes that nitrogen source, slams some other elements into it, and makes amino acids. And those amino acids go on, and they make proteins in the plant that's needed. So, it's something that we're actually a lot more familiar with than we would think. But we know there's several different ways to feed nitrogen to plants, right, or amino acids, but how does it move in the plant? Why does that matter? So this is the vascular system of a plant, phloem and xylem. Some people have heard about it, some people have not. Xylem is a one-way system. Think of it like your gut. It goes from your mouth down and out. Same way with plants, except in reverse. It goes from the roots, up the stem, out the leaves. One-way system. If it's not a one-way system, you might be having some issues. The other option is the phloem. think of this like your blood, the plant sap. It is a circulatory system. It continuously cycles throughout the plant. It can go from the roots to the stem, to the leaves, back to the stem. Oh, there's a flower over here. Oh, there's a corn cob. It continuously cycles. And actually, that phloem recognizes nitrogen, which we're either applying as that ammonia, urea, amino acids, however you take it, and moves that nitrogen throughout the whole plant and continuously cycles it through the plant until it needs it, pulls it from that vascular system, and uses that nitrogen to make amino acids, to make its own proteins. It all keeps linking through. So I wanted you guys to be a little bit more familiar about what kind of amino acids you might see in industry. Now, I have another molecule up here that everybody's going to look at and go, what the hell is that? Well, that is actually a glyphosate molecule. You look right here, this is your glycine, which is an amino acid, and then it's slammed an extra phosphorus to it. So you guys know amino acids. This has been around forever. It's just in a little bit different form. So see, you guys know what you're talking about. Some other ways you might see amino acids come up in industry. The big one I have seen, honestly, is this hydrolyzed protein, which means that they have taken a protein source, mixed it with an enzyme, ground it really fine, and then put it in a jug or in a bag. You might have some that are really, really broken up, really fine, but you might also have some that are in pretty big chunks, and that is hard for the plant to utilize. So there is a lot of variation when it comes to hydrolyzed proteins. They're not bad, they serve a purpose, but I think when people kind of think about amino acids and have a hard time with consistency of results, well, you might have a consistency of your product issue. So that is an option. Another option that you see more so in the animal industry are these straight amino acids. Lysine, lysine, methionine, cysteine, those sort of things. Those are actually seen quite often in confinement systems. So think like pigs, chickens, where their diets are so heavily regulated. And they usually come in a crystalline or a powdered form. Now, I've actually had individuals that ask me, well, why don't I go get a big pallet of glycine and start dumping it into my tank? Well, the beautiful thing about amino acids is they're friendly. They love to be paired up. They love to have friends and to make those connections. Which sounds really awesome until it makes cottage cheese in your tank. It might be fine. It might be able to sit by itself and not pair up with anything that's a problem, but then you might also run into issues with it binding up something you didn't want it to. So please do not put straight amino acids in your tank, or if you do, don't call me. I do think there is some application for this in like an in-furrow system, where even if you're not directly feeding that plant, you might still be feeding the microbes that are in the soil system, which, as you know, happy microbes make everything a lot happier as well. The last option that you'll see, or that you're starting to see a lot more, is, amino acid chelation. And this is my favorite. This is what I specialize in. This is what I do all day, every day. Ask Tyler, it's a lot of fun. But we actually take an amino acid, a singulated amino acid, and we pair it with a mineral ion or a metal ion. And think like zinc, copper, manganese, magnesium, one of those ions. And when they bind, they make this really pretty and really cool heterocyclic ring structure, which that just means that it makes this ring structure. It's happy, it's holding hands, it really doesn't need to worry about dancing with anyone else because it is content with its partner. So, why does this matter? How does this make a difference in your guys' world? Well, if we can take this technology here and give it a different route of absorption into the plant, it increases bioavailability. And when you increase bioavailability, you increase your ROI, which is really the ultimate goal, right? You can grow the best corn in the county, but you can go broke doing it. So ROI is our big objective here. So when you apply some of these other products in a foliar form, you have to go through, this is a cross-section of leaf, I apologize. You have to go through these in the guard cells, but you have to go through the stomata that are on the underside of the leaf predominantly. There are some on other leaf structures or stem structures, but predominantly it's on the underside. And so your bigger molecules have to go in through the stomata. Your molecules that have a charge, so think like magnets, positive and negative, they would interact with the leaf surface and kind of get hung up, kind of get stuck. Well, if it's stuck on the leaf surface, it's doing about this much work for you. So you have to be able to get it into the leaf. There's already so much that we're trying to slam in through the stomata that's where this heterocyclic ring structure comes into play. This molecule right here is neutral. It has no positive charge, it has no negative charge. It is happy chilling out on its own, and because of that, it's actually able to pass through the cuticle, the outside structure of the leaf. So, you mix it in a tank, you not only are getting your herbicides, your pesticides, whatever, some of your inorganics, those are going in through your stomata, but amino acid chelation doesn't have to use that. It can, but it doesn't have to. It can go in right through the surface or right next to the stomata. So you're actually able to get a secondary site of absorption just because of this little ring chemistry here with an amino acid. Now, you have to be sure that you use the right chemistry. You have to be sure that you use small sizes, because even if you are trying to pass through the cuticle and you are neutral, you have to make sure that it's small. So there are several things that you can make it sound easy. It's not always that easy. So a lot of people ask, why do we use minerals? Why are we focused on this? Because, my favorite mineral in the world is magnesium. Everybody goes, oh, I have too much magnesium in my soil. I'm fine. Well, is that in a bioavailable form? You might have a large amount of magnesium, copper, zinc, whatever in your soil, but is it really getting in there? So like I said, this technology, amino acid chelated technology, started in about the 1950s, so it's been around a long time. So I really love showing this slide as to why minerals matter and why amino acids matter and why, if you combine them together, you can really get after it. So this is just a slide that I took from the app. It's just a nutrient removal by crop app. This was designed by the Hefty brothers and the International Plant Nutrition Institute. Free app, you can plug in whatever yield you want and it spits out. But every single year, every time you take grain off of that field, this is what you're taking off in that grain. And like I said, you can change your bushels, you can change your crop. This was just a great example. But how many times do we put copper back in to our systems, or manganese, or zinc? And how many years has that ground been in production that we have not supplied it? So it really shows an impact, and it's kind of starting to show why dumping more and more nitrogen on, we're seeing less and less dramatic effects, because that plant is needing essential nutrients to help build its structures, that just putting nitrogen on isn't really a good enough band-aid anymore. We're seeing that gap. So the big keys here is that amino acid technology is not new. We've seen amino acid chelation since the 50s. We've all used glyphosate, or we've at least heard about it. So that's something that we've seen. We just didn't really ever make that connection. Or maybe you did, and then you're smarter than me. Amino acids are a great way to smuggle nutrients. We're able to get that twofer usage out of it, both from the amino acid and the mineral. You can directly feed the plant with low input building blocks. The plant does not have to alter that substance, that amino acid chelation, after it goes into the plant, or that amino acid. It's able to directly use it to build what it needs to. If you provide something that is a bigger, like closer to a protein size, then it has to chunk it apart. If you feed something smaller, like your anhydrous ammonia, or 3200 or whatever, you're going to run into issues with that plant has to use energy, slam it with some other metals, and make an amino acid to then make proteins. So the last thing, the big thing that I love is the bioavailability. And we work with this in every organism we work with, whether it's humans, animals, companion animals, pets, and now plants. And we make sure that bioavailability is our key. If we can get more into the plant, we're going to get more out of the plant. So, that was really dense. And I'm aware it's really dense and y'all are looking at me. I thought I'd stop for a second and see if there are any questions that I can clarify while we're still thinking about the chemistry before I brainwash you and continue going and putting my data where my mouth is.
Are you using different amino acids with different nutrients?
Yes, sir. So we use a proprietary blend of singulated amino acids. We tweak it a little bit based on our target crop species. My formula for oranges is a little different than my formula for corn. But it's actually the same technology we also use in our animal line. We just use a different ratio of different amino acids and different minerals. So there's some research out there about targeting specific tissues with specific amino acids and getting really into it. For example, your brain loves arginine. Okay? So to get more zinc into the brain, some researchers are trying to use a zinc arginine amino acid chelate to specifically target that tissue. I think that gets really, really in depth and I'm not that smart, but it's a cool theory.
What micronutrient does glyphosate affect the most?
I hear that usually it ties up your copper for one, which is also your biggest component of plant health. And then also, usually manganese or magnesium is the one that people are worried about. Like I say, everybody says they have too much magnesium. Not everyone, lots of people. So that manganese is really a hazard as well. But when they first introduced Roundup or glyphosate into the market, they used to say that it was safe enough and sweet enough it could replace the coffee creamer in your coffee, because that glycine molecule, as it sits in its crystalline form, is actually very sweet. And so that was kind of their marketing ploy at that point. I don't recommend that. Don't do that. But it's interesting. Yeah.
So with your chelation process, there's different, I'm thinking of the inorganic, the other ones, just so I can get my mind straight compared with it. Would you say yours is 100% chelated? Because I know some of the real cheap chelation, others, only a part of it is and the rest of it's tied up junk.
Yep.
So I was just curious.
Yep, so we focus on actually the animal definition, which is AFCO. Plant side is APFICO, because that makes sense. But AFCO has a very strict definition of what it takes to be an amino acid. And one of those is it has to be in a 1-to-1 molar ratio with amino acid to mineral, and we ensure that that is always met. So we always make sure that we do 100% chelation. When you were to test that substance, we are able to test it and actually make sure that we meet our quality standards as well. Because if you don't chelate everything, or if you add too much amino acid, it might start playing with things that you may or may not want it to play with. So we keep very, very strict quality control on that. But yes, you are correct. There are some that like to tweak the definition a little bit. Okay. So everybody good? Now I get to show off a little bit. So this is just a slide that we like to do. Our ingrained is our main product. It is a blended product that can be added straight to the tank, 16 ounces per acre. It's my baby. I developed it in 2019 and it has wowed me more than I ever expected. We have our Deluxe and Lux, which is actually more on your turf side, your sod side, more of your ornamental landscape. And then we also have all of these individuals. and actually a few more that we've added since then. So if you want to make your own tank mixes, that's an option. If you want to just grab something off the shelf and roll and go, that's an option as well. So we like versatility and we like ease, because if it's difficult to use or not exactly what you want, the likelihood of you using it goes down. So we like that versatility. All of these are liquids. They're beautiful blue-green, and they like to stay in suspension. Well, here's just the label of ingrained, just to give you an idea. Like I said, I really like magnesium, guys. Y'all can come at me, but it's a really cool mineral. But we also have this other blend. Something to note is boron. So when you come up down here in the derived from statement, you'll actually read it as boron amino acid complex, not chelate. And this is because boron at a chemical level cannot be chelated based on its number of valence electrons, which is just a really fancy way of saying instead of having 2 arms to hold on to that amino acid, it actually has 3. So then it's like trying to hold on to a toddler with 1 hand and target. You're going to end up with extra stuff in your cart. Still a great product, still has a lot of that amino acid technology to it, just something I want you to be aware of. That way, if you go home and read it and go, well, Sarah lied. Well, technically boron and potassium are the 2 minerals that we run with that do not have the ability to make that heterocyclic ring structure. So, I would love to say this was Tyler-nized corn. You can guess that it's most definitely not. This was done in Illinois. This was in the first year of what I call stupid testing. So we did testing all over the US to make sure that if it got sprayed at the wrong amount, if it got sprayed at an inopportune time, if it got sprayed directly onto tassel or flowers or whatever, just to make sure that this product was safe. We mixed it with every herbicide we could come up with, and fungicide. And so this was one of the results we saw. Now, this is an awesome jump. I'm going to be honest, this is not always what you'll see. With corn, we're pretty consistent out of 3. We usually say closer to about a 6 bushel bump a year. When it comes to a really terrible year, we actually do better. We thrive when conditions are less than optimal. And so we usually see 6 in a good year. We can get up to that 12. I just saw corn in Iowa right now that were projected to be 20 because they were not able to get into the field and missed a lot of nitrogen. So we'll see what happens, but that's kind of cool. We've seen results where we reduce the tip back problems that you'll see. This was in Iowa a couple of years ago, and you can see the ingrained ears are just, they're more consistent, they're more full, they had the energy to keep going, whereas these control ears kind of started to peter out after a while. The root systems were also just amazing on these. That's a difference. We had a guy that was like, oh, your stuff doesn't do anything, and he was on top of a grain bin, and he's like, I think I see something. So he goes in and gets his drone, and he's like, holy crap, yes, I do see something. So this is actually a study that was done in direct comparison to another chelated product that is on the market. They do not use amino acids, they use an EDTA as their ligand, which does get into the plant a little bit better as well, but we still won, we're still better. We are much smaller, we make that heterocyclic ring structure. Not saying EDTA is bad, just saying that I like my product better. This was in southwest Kansas in Milo in a year that we had a drought. This was one of the few fields that actually even got harvested in that area because the water was so lacking. A lot of the Milo didn't make heads. So we have the field here, this was the road, so they weren't really worried about that. But this was the controlled test strip, and they got about 24 bushel, 25 bushel in that test strip, and the rest of it got about 53 bushel. So that was exciting to see. That grower was ecstatic. We've done wheat in Kentucky. So we've done wheat in Kentucky, so you can see the difference between the control and the ingrained. We've done Eastern Kansas beans, where the farmer said that the beans were just not doing well. He just felt like they were not great. It was really down on himself, and he tried the product, and your stuff really works. Except he did not say stuff, but that's okay. I'll take it. We've done soybeans. We've done soybeans where you can see the line. We've done our product in conjunction with other products. We're trying to see where our faults are or where our issues are. Because I would rather find it myself or find it with the group we work with rather than your customers or a customer going, hey, I made cottage cheese, or hey, this didn't work. So we've tried a lot of different products in conjunction with this because I do want to see where my pitfalls are and make sure I can get that handled before someone else has a problem. And I really haven't found it much. The only thing it does not like to play nice is your phosphates. But I don't know that phosphates like to play nice with much, orthophosphates. We've tried it on silage this was actually in Minnesota. We've tried it on baleage in Georgia. This was just a really cool slide. We have not been able to do this again. The group changed hands. But basically, we wanted to see what it did from a water standpoint. And I think a lot of you guys can contest that water is a huge issue, one way or another. Some folks have too much water. I know a lot of folks that had too much water, and it made me really sad. But, so they did this study in central Nebraska, and they looked at how much water there was at the beginning when the planter went through, and how much water there was at the end of the study. Now, yes, they did get rain, I promise, but they were able to see how that plant was able to utilize the water and how it was able to do it effectively. So we still saw this bushel yield bump, which is excellent, but the really cool thing with this study is we saw that 98% of the water that was there when we started, they still had that amount of water at the end. So we were able to use water more efficiently and more effectively. And part of this is really cool from a drought standpoint, but this also actually shows how well it can work in a water lodging situation. Because when that plant is hungry and goes, I need more minerals, I need to be able to feed myself, it's going to start pulling in water into those roots, right? Well, when it pulls in water into those roots, if it has enough, it's going to waterlog and it's going to lodge and fall. So this actually shows that the plant was able to use water much more efficiently. So that was something that was really awesome. And I also debated about showing you guys this slide. This is something that we've just seen in the last 2 months, and these are screen grabs from a video that one of our growers in Illinois is doing, and he's super excited. Like I said, our product can mix with Roundup just fine. And he was having some Roundup resistant weeds or glyphosate resistant weeds, like really bad. So he sprayed weeds that were just straight glyphosate. It would ding them maybe a little, but they were doing just fine. So he decided to mix glyphosate and amino acid chelated mineral product called Fortify that we formulated for a group called New Fields Ag a couple years ago. And he's like, they just keep dying. This is awesome. This is about 3 days post-application, and this is about 10 days after. And he said fields that he has struggled with for years with weed issues, he's actually able to finally get that knocked out. Now, this is not proven. This is something we're working on, but it's something that's really freaking cool. So I want to thank you guys for your time. I really appreciate you being out here. I know Michael appreciates it. I love showing off my product, our products, Tracer's products. It's a company based out of Southwest Kansas. Actually, it is my family's company, so I'm second generation. So I don't know if that deters you or not, but that's where we're at. So we're really excited. We like to get more involved and maybe move some stuff local. So if you guys have any more questions, please feel free to ask me. The QR code should take you to my contact info. I have some brochures over here on the right, also with my business card. We have a website, There's lots of ways to get a hold of us, and we can see what you guys need.
Are there any questions?
Yes, sir.
How much have you been able to cut back on actual nitrogen then, like anhydrous or anything, and still keep your yield?
So we've been playing around with that, and we joke that it's winning a trial with a yield bump of 0. And so we've been working on that, especially in Minnesota right now. And this year was not great. A lot of guys were not able to get into the field with nitrogen, so we're kind of waiting to see what those results are. Some of those weren't nitrogen reduction on purpose, just because they couldn't get machinery in the field. So we are working on that. We have had growers that have put, they used to put about 0.9 pounds of N per bushel of corn, and now they're looking closer to that 0.7, 0.6 number. But that's unofficial right now, so you didn't hear from me. Or maybe you did.
Have you done any rate trials?
One dose versus 2.
Or 4X, or 5X, or?
So I have sprayed straight concentrate onto plants and got the best yield I've ever had. However, that is not economically viable. So we do have a group out of Kentucky that looked at doing 1 pass versus 2. Like I said, this is 16 ounce per acre. And he saw about a 7 bushel bump over. Now granted, when corn was $7, it made a lot more financial sense than when corn is $3. This product runs $6.95 a dose an acre. So the ROI kind of fluctuates as the markets fluctuate, but he was really pleased with the product, and he's doing a second dose or another 2-dose study this year because he's loved it so much. Sometimes the issues I have with research is guys end up liking the product well enough that they get excited and put it on everything. So all my cotton trials, I have no control this year, so that's fun. But, yeah, you know, I don't want to discourage it, but at the same time it would have been really cool to see that. So yes, we are kind of working on that. If you are doing table crops, like your onions, your lettuces, tomatoes, things like that, usually we do smaller doses, but more often, so we'll pulse the product more.
Can you mix in like some of your other, say boron or something else with the ingrain?
Yep.
To get the extra boost of a certain nutrient?
Yep, you are more than welcome to play with it. All of our individuals have the same amino acid chelation technology in them, so they're happy, they're bound, they're ready to roll. And some guys like to spike it, some guys like to completely make their own cocktail. We do have some guys that buy in a large enough bulk. They give us a formula and say, hey, what do you think of this? It goes to me. I usually do a test of it here in Almena, and then we kind of negotiate if something needs to happen. All of these products, one of our most concentrated products is a straight zinc. It's about an 8.5, but that's 8.5% metal. On a dry matter, most of our products range in that 40 to 45% dry matter. So they're pretty stout. So we have to make sure that they stay in suspension.
Any other questions? If not, can we have a big round of applause?